Hey guys, one last video for the night. All right, so I've got something. This is almost a culmination of all our gas laws. Uh, Everyone we looked at: Boyles, Charles, Henry. We haven't looked at Henry's yet. Boyles, Charles, Gay-Lussac, Avogadro's, the combined gas law, the ideal gas law. We can separate them into two top categories. One, if there's a change, we don't use the ideal gas law. If it just wants to find something with all the variables, we will probably be using the ideal gas law. So let's look at some of these. I've got some nice little surprises for you. So, and this is probably how I would recommend that you guys do this, is go through the problem. I've got a volume measurement. I've got a pressure measure. Oh, it's allowed to expand. That's a word that means something to me. That means there's change going on. So I'm going to use one of the other gas laws. So I'm going to write down what I've got. All right, I've got my first pressure, which is 925 torr. Again, that's one of the pressure units. And I've got a volume, so we're going to call that volume 1, 625 milliliters. And it's allowed to expand at a constant temperature, so I'm not going to have to worry about volume or temperature until its pressure now is 748 torr. Okay, and what's the volume? Now this ought to be really easy for you guys now. Volume, I don't know. Pressure, volume, what have we got? P1 V1 equals P2 V2. What have I got to do? Plug and chug. Just plug and chug. So that's 925 torr times what? 625 milliliters equals 748 torr. And V2. So what I do, I gotta get V2 by itself. 740 divided through by 748, which is unity, R1. And that means I gotta do it on that side. Oops. Calculator. So 925 times 625 divided by 748. That gives me 772 milliliters. Let's see if that makes sense. V2 equals 772 milliliters. 772 milliliters. Here I can use my popsicle stick. Let's see if this makes sense. Let's see if it makes sense. So temperature is constant. All right, so pressure went from 925 to 748. What should volume do? Pressure went down. Volume goes what? Goes up. It went from 625 milliliters to 772 milliliters. That makes sense. That makes sense. Good job, guys. Now let's look through some of these problems and see if we can identify what we've got. What will have to happen to the temperature of a sample of methane? Methane is 1 liter at 735 torr and 25 degrees C. Volume, pressure, temperature. Oh, pressure changed and a volume changed. Well, I'm going to tell you what we've got. We've got a combined gas law. That's going to be a P1 V1 over T1 equal P2 V2 over T2. Identify, plug and chug. And we might do this later. Again, as I go down through some of these, a sample of 4.18 moles. Now that tells me it's either going to be ideal Avogadro's. We do very little Avogadro's, probably ideal. At 18 degrees C, occupies a volume of 24 liters. Under what pressure is this in atmospheres is this sample? I'm going to tell you. PV equal nRT. Nothing changed. It just wanted an identification. All right, let's look right here. This is number 4. A steel cylinder containing 79.8 moles with a volume of 10 liters is under what pressure at a temperature of 24 degrees C? Again, what do we got? PV equal nRT. Atmospheres, know what R we're going to use, 0.0821. I told you that's the one that most of these problems like. A steel cylinder with a volume of 25 liters contains nitrogen under a pressure of 148 atmosphere, temperature 25. How many moles? Easy. PV equal nRT. Then just identify it. This is a little bit more confusing. Let's see what we got. When a steel cylinder of oxygen with a volume of 14.5 liters was used to supply oxygen to an oxyacetylene torch, the pressure of the cylinder changed from 208 to 201. I used some oxygen, so my pressure went down. The temperature of the oxygen was 25 degrees C at the times of both pressure readings. The question is asking, and that is the equation for what's going on here. So I had a change from that pressure. 25 degrees C at the time of both pressure readings. I'm thinking that doesn't matter that much. Let's see here. How many moles and how many grams of oxygen? So you got to find moles first. All right, so pressure, volume. Well, I'm going to tell you how we're going to do this. This is a two-step problem. I would do PV equal nRT at the 208 atmosphere one. Then I'm going to switch around and do PV equal nRT at the 201 atmospheres. Volume does not change. Temperature does not change. So the only thing that really changed was pressure. Now you can plug and chug that in and it's going to get your number of moles. And we'll do this tomorrow night, or we might do it in class tomorrow. But that's going to give me the two different molar, the number of moles at those, how much was used up. And once I find out the number of moles, then I can convert into grams of oxygen. Okay. Now, after I know this, you know what? Somebody did not balance that. We'll let you balance that at home, or I'll do it right now. So I've got 2 moles or 2 carbons there. That means I need to have 2 there. Now I've got 5 oxygens. I've got 2 hydrogens here. That's good. So I've got 2, 4, 5 there. All right. So I'm going to need to get 4. I need to get 3. All right. No. I need to get 6 oxygens on that side. That gives me 10. Let's do some stuff here. I got to do 3 here. All right. Now I got 4, 10, 3, 6. I got to get 6 hydrogen. That's 12. I got to get 6 on this side. Now I'll fool with that later. I'm going to think on that one. But I'm going to have to get my stoichiometry right. I'm going to have to balance that equation. We're going to have to do that to answer B. And we'll get to that tomorrow. Okay? It's late. We'll have fun tomorrow. We'll work some of these problems. And have a good evening. And Coach Scott says get a good night's sleep. And we'll do some more chemistry tomorrow. Talk to you later. See ya.